In Chapter 7, Section 1, we're going to look at the Cartesian coordinate plane. The Cartesian coordinate plane, as some of you may call, is the graph, but you need to know basic terminology. Now, some books, some teachers call it the rectangular coordinate system. The rectangular coordinate system is based on your ordered pairs that form these little squares or little rectangles. The horizontal axis is the x-axis or the abscissa. The y-axis or the ordinate. The x-axis is just a number line that is laying horizontally. The numbers to the right are positive. The numbers to the left are negative. The vertical line, the y-axis, the y values are positive going up and negative going down. The x and y axis separates your plane into quadrants. The first quadrant is the upper right-hand quadrant. Going counterclockwise, we have quadrants 2, 3, and 4. And these are numerals that are Roman numerals that I'm using. The two axes meet at a point called the origin. And the origin is the beginning where you're going to start numbering your ordered pairs. The ordered pairs that we are going to start talking about have x and y values. The x value in the first quadrant is positive. The y value is positive. The x and y values in the second quadrant, the x's along the x-axis are negative. The y values are positive. Both the x and the y values are both negative, negative, and negative in the third quadrant. And the fourth quadrant, we have the x values being positive and the y values, being negative. And together, that is the rectangular coordinate system. When we ask to determine whether or not points are solutions to an equation, determine whether or not the ordered pairs are solutions. The solutions mean that when you plug in, substitute in the x and the y values for the x and the y, both sides of the equation are equal. The y value is 4, the x value is 2. 6 minus 2 tells me that 2, 4 is a solution because both sides of the equation are equal. If I use the point 0, 1, where the x is 0 and the y is 1, 1 equals 3 times 0 minus 2, the orders of operation tells us that no, 1 does not equal a negative 2, therefore 0, 1 is not a solution to that system. When we are making a table of values to determine the completed values for the equation, if I have y equals 2x minus 1, I tell my students to give me values that are negative and values that are positive. When you have a linear, the x value are going to be the independent values. Independent literally means it does not matter what values you substitute in for x. I tell them typically to give me, say, 4. So negative 2, negative 1, 0, 1, or 2. You can give me 5. That's okay. I'm going to substitute in 2 times negative 2 minus 1 Negative 2 times 2 is a negative 4 minus 1 tells me it's a negative 5. If I substitute in a negative 1, negative 2 times 2 times negative 1 minus 1 is a negative 3. If I substitute in 0, 2 times 0 is 0, minus 1 is a negative 1. And I would continue on this path of just plugging in, substituting in a number into the x value and working the orders of operation like you should know how to do. Y equals 2 times 2 minus 1. 4 minus 1 is 3. I have my table of values. I have the input values and the output values. Input values are those independent values that it doesn't matter what you put in, and then you're going to work out the output values. When we start graphing then, without a calculator, and guys, this is all without a calculator, and if you're in my classes at my school, I physically am going to take your calculators away from you, and you're going to have to be able to graph these linear pairs without a calculator. The first thing you notice in this particular problem on 10, this is called standard form. It is not in y equals mx b form or slope-intercept form. It's in standard form for a linear equation. I know this is linear because my x value is 1. Now, when you were in Algebra 1, your teacher probably told you to solve for y and then use the slope-intercept form. In my classes, we need to do them a little bit faster. We need 2 points, and I'm going to substitute a 0 in for the x, and then I'm going to substitute a 0 in for the y to get my 2 points. I like 0 because 0 times anything is 0, and it makes it go away. So y equals 6. 2 times x plus 0 equals 6. I'm going to divide by the 2. X equals 3. So I have 2 points, 0, 6. And remember, to graph, we do not go right or left if the first number is 0. It just says sit there and go up 6. 1, 2, 3, 4, 5, 6. The ordered pair 0, 6 is graphed on the y-axis. The point 3, 0 start at the origin and go right 3. And then you are going to connect those 2 points. And I am also going to need you to label the points if you're in my class. You only need 2 points to determine a line. Use your straight edge, draw your line, and then put your arrows. It is a line, so it's going to go on infinitely forever. Moving on to problem number 20. The equation is a negative 3x minus a 2y equals 12. I notice it is in standard form. I'm going to use my 2 points where x is 0, and then again when y is 0, negative 3 times 0 minus 2y equals 12. The negative 3 times 0 goes away. I'm going to divide by the negative 2, and it tells me y equals a negative 6. I'm going to write down the problem again with the 0 substituted in for the y, and I'm going to divide by the negative 3 and get the negative 4. Drawing my y-axis, my x-axis with the lines on the graphing paper makes it neat. 0, negative 6. 0, 0 means I do not go right or left, and now I go down 6. 1, 2, 3, 4, 5, 6. Put a dot, label the point. Negative 4 means I go left. 1, 2, 3, 4. There's negative 4. Here's my point. Negative 4, 0. These x and y axis connect my 2 points with a straight edge. Put arrows on the end because these are equations of lines. If you have the equation and it is in slope-intercept form, problem 32 has the equation solved for y already. If the equation is already solved for y, that is y equals mx plus b, or slope-intercept form. In slope-intercept form, you're going to start at your y-intercept. The y-intercept is the number that's added or subtracted to the variable that has the x. I have nothing written here. That means 0. I'm going to start at 0, 0 on the y. That is the y-intercept. Then I'm going to do what my slope tells me. My slope, remember, is rise over run. In our case, I have a negative, so I'm going to fall 1, 2, 3, 4, and write 1. You may be asking, why write 1? What number can you divide by and not change the value? 1. I'm going to go down, and notice as you read your graphs from left to right, your line is going to be descending. It's going to have a negative slope. Again, my students, guys, you're going to have to label your points. I need to know what you're counting by, and I need to know what these points are. I went right 1 and I went down 4. So my ordered pair then is 1, negative 4. As you go through these graphing, remember we had special lines that do not have an x-intercept, or it doesn't have a y-intercept. Those are two special cases of lines. And we only have one variable in those equations when that happens. If you happen to have an equation that says x equals a negative 3, where on your ordered Cartesian coordinate plane does x equal a negative 3? Remember, the x is the horizontal. Your number line goes positive to the right and negative to the left. So x equals a negative 3 at negative 3, 0, and at negative 3, 1, and negative 3, 2, and negative 3, 3, and negative 3, 4. It is also at negative 3, negative 2, negative 3, negative 3, negative 3, negative 4. All of these points have a negative 3 in common. So the equation that says x equals a negative 3 is along this vertical line, this line that's straight up and down. If you have to graph the line, you actually have to connect all of those points. Anytime you see x equals, that is going to be the vertical line straight up and down. And some of you may be thinking, well, I thought the vertical line was the y-axis. The y-axis is when the x value is 0. The equation of the y-axis is x equals 0. Anytime you have an x equals a number and you are to graph a linear, go to where the x equals the number and you draw a vertical line. And if you want to go ahead and pick a couple of points that start with 4, comma, and something, that will tell you how your graphs are going to look. Likewise, if you are looking at problems where y equals a number and there is no x value, the y value is the second number of your ordered pair. You can write a couple of them. It doesn't matter which one, as long as your y value is a negative 1. 0, negative 1, 1, negative 1, negative 1, negative 1. It really doesn't matter what point you pick, but to get your line, it'll tell you where you're going. The 0, negative 1 means I do not go left and right. I go down 1, 0, negative 1. 1, negative 1 tells me I go to the right 1 from the origin and down 1. Negative 1, negative 1 says to go left 1 and down 1. And I think 3 points are probably sufficient for you to see that anytime you have y is equal to, you are going to have a horizontal line. All of the y values on this line are at y equals a -1. Applying graphing to linear relationships, if you have word problems, in particular my classes, we have these word problems. Word problems are nothing to be afraid of. Look at problem 44. Suppose that the daily profit from an ice cream stand is given by this equation, where N represents gallons of ice cream mixed used in a day, and P represents dollars of profit. Label the horizontal axis N and the vertical axis P. Okay, they just told you what to do. I'm going to go in here. Straight up and down lines are called vertical lines. Horizontal lines are straight across, just like the horizon. It says N represents the gallons and P represents profit. Label the horizontal axis N. Horizontal axis that was normally X, we're going to name it N. It says name the vertical axis P, standing for profit. So we're going to label our N and our P. Graph the equation 2n minus 4 for non-negative values of n. 2n minus 4. Y equals 2n minus 4. In the case of 2n minus 4, we notice that we have one variable on a side by itself. It looks like y equals mx plus b. And you can't see any of what I'm writing. I am so sorry. Our y-intercept says, hey, start at -4, 1, 2, 3, 4, and do what the slope says. The slope is 2 over 1. We're going to go up 2, right 1, up 2, right 1, up 2, right 1. And as many as you're going to graph, you're going to need to label. I started at 0, -4. Start at the origin, go right 1, down 2. Start at the origin, go right 2. Start at the origin, go right 3, and up 2. And it says to graph all of the non-negative. Well, non-negative means 0 and positive. So in this case, you are not going to have an arrow then starting from 0. You're starting at 0 and only drawing that ray to the up and right. These problems, just because they're word problems, are not difficult problems. So be sure that you go through and work those, and have a great day.